Hi everybody, so we're going to be talking about how to prove lines parallel. Pretty much what's going to end up happening is that we're going to be able to use the converse of the postulates that we had yesterday and prove that lines are parallel. So for example, with the converse of the alternate interior angles postulate, if two angles and a transversal form alternate interior angles that are congruent, then the lines are parallel. So say I was given this graphic to the right, and we're going to do the same diagram for each of them. Say they told us that we have these two are congruent, and these two are also congruent. Because our alternate interior angles are congruent, therefore line L is parallel to line M. Right? The same thing can happen right here with our alternate exterior angles. If two lines and a transversal form alternate exterior angles that are congruent, then the lines are parallel. So they have to tell you that these angles are congruent. And if they are congruent, then and then only can you say that line L is parallel to M. And that's because you need both the conditional and the converse to be true. Right? The same side interior and exterior angles are similar. You'll remember, though, that they become supplementary. Another way to also say same side is consecutive. So you'll have like consecutive interior angles or consecutive exterior angles, and we talked about this yesterday as well. I want you to be familiarized with both versions of the name. So if two lines and the transversal form same side interior angles that are supplementary, then the lines are parallel. So pretty much, say we've got angles 3, 4, 5, 6 here, and we can say that the measure of angle 4 plus the measure of angle 5 gets us 180, and there we go. The measure of angle 3 plus the measure of angle 6 is 180. Then, therefore, line L is parallel to line M. So with that same concept, we're going to go ahead and do the same side exterior angles or consecutive exterior angles. So again, it's the same exact stuff right here. You want to be proven, you want to be shown that your two exterior, same side exterior angles are supplementary. Then you can say that the lines are parallel. So if angle 1 plus the measure of angle 8 equals 180, and the measure of angle 2 plus the measure of angle 7 is 180, then you can prove that line L is parallel to line M. This last one is the converse of the corresponding angles theorem. So remember, this is our copy, paste. So if two lines and a transversal form corresponding angles that are congruent. They have to be congruent first. Then the lines can be considered to be parallel. So they tell us that this angle is congruent. This is another angle pair. We've got a third angle pair and a fourth angle pair. Then you can say line L is parallel to line M. So let's go ahead and work on some examples here. All right, we are going to use this diagram to help us answer these questions. Pretty much, we're going to be given information and we need to prove if there are lines are parallel from that information, and if so, why. All right, angle 14 is supplementary to angle 15. So let's look at it, angle 14 and angle 15. Well, if you're looking at this transversal here, and these lines, angle 14 and angle 15, would be same side interior angles. So we would write that our justification for this, or our reasoning, remember those two proof columns, is the converse of the same side interior angles. And if we abbreviate it to int, that's fine. If you say same side, or if you said consecutive interior, I would be okay with that as well. But using this knowledge, that angle 14, the measure of it, plus the measure of angle 15 is equal to 180, we can therefore prove that line L is parallel to line M. All right, now let's look at another pair right here. And I'll go ahead and highlight this so you know which color we were on. Let's switch to a purple. All right, angle 4 is supplementary to angle 16. Well, if you turn your kind of graph around, you'll notice that our transversal in this case is actually line M, and these are our two lines. And if that's the case, then these are going to be same side exterior or consecutive exterior angles. And I'm going to write consecutive this time. So it's the converse of consecutive exterior angles. Again, you abbreviating on this is not an issue for me. All right, and therefore we can prove that line N is parallel to line T. And that's because the measure of angle 4 plus the measure of angle 16 is equal to 180. All right, now let's go ahead and look at this blue. Angle 4 is congruent to angle 2. So now we've got angle 4 is congruent to angle 2 right here. And you can see that's a copy-paste or corresponding angles. So we're going to write converse of corresponding angles. And therefore, line L is going to be parallel to line M. And that's because our transversal for that one was line N. And the lines that the transversal cut and intersected were lines L and M. Our next one is angle 1 is congruent to angle 6. All right. Well, that's awesome. They're vertical angles. But hey, there's not a converse of vertical angles. So that means nothing There, nothing, no parallel lines. You don't need parallel lines to prove that vertical angles are congruent. That was already the case, remember, from chapter 1? All right, now let's do angle 9 and angle 2. Angle 9 is congruent to angle 2. Well, no matter which way you turn it, they're not necessarily congruent. You can't prove anything. They don't have a relationship. We've been told that they're congruent, but that's it. So no relationship and no parallel lines. Tough cookies. It's just what happens. All right, then we've got angle 7 is congruent to angle 12. All right, let's look at this one. Angle 7 is congruent to angle 12, which means our transversal is line M, and it's cutting lines N and T. And because these are alternate interior angles, we can use the converse of the alternate interior angles and prove that line, where were we? Line N is parallel to line T. All right, we've got our last two. Angle 4 right here is congruent to angle 13. Well, these are on two different transversals. They're like in another world over there. And because there is no common transversal, we can't prove that there are parallel lines. So we're going to say no common transversal, no parallel lines. And our last one says angle 1 is congruent to angle 11. This is the same thing. They don't have a common transversal, and they're not parallel lines. Now, you could work your way up, and once these lines have been proven parallel, you can find their measures, but right now, that's not the case. And we can't prove that both of those lines are parallel first, just from what they've given us. All right, so that's what I got for you. All right, good luck. You got this.